Hello all and welcome back to my YouTube channel. We are learning a series of AutoGen, which is an agentic framework developed by Microsoft. In the previous videos, we have seen how a AutoGen agent can talk to multiple different agents and how the different conversation patterns are provided by the AutoGen in order to simplify a complex task or in order to solve a complex task. Let's do a quick recap of what we have seen till today. So we started with a two-agent chat framework. In two-agent chat, we have seen agent A and agent B, how they can communicate in order to accomplish a task. And this was the very simple example that we have seen, where we have introduced a terminology or reflection with LLM in order to generate the summary of response generated by A, and that we pass to the B, and that's how the final response, that is the summary of response that is generated by the agent. Then we switch to the second conversation pattern, that is sequential. In sequential chat pattern, we have seen how the different agents can talk to each other in sequence, where agent A is your common agent, which talks to B, C, D, and E in sequence. And then we have introduced a term called carryover, which is carryovering the summary generated by this particular two-agent sequence to the next sequence of agent, and that's how the final response is generated. And we have seen how this agent helps to simplify a complex task, and we have seen several examples as well. So if you have missed this particular part, then I would highly recommend go ahead and check out the playlist. The link is already available in the below description. Then we have seen the third conversation pattern, that is the group chat. So in group chat, we have seen how group chat helps us overcome the challenges that we have faced in sequential, where we were not able to solve a complex task, or if your task involves multiple steps, then the two-agent chat was not sufficient in order to accomplish the task, or where the sequence of the task is not defined, the agent needs to select the proper sequence, and that sequence also the agent should select by their own. And in those cases, we have seen how group chat agent helps, where we have a group chat manager which decides next which agent to call in case if the sequence of task is not known to us, or the sequence of tasks can be changed in between whenever the agents are solving tasks. So in that case, we have seen how group chat manager is helpful in order to select the next agent. And in group chat, we have seen a group chat manager has the feasibility in order to select the next agent, where we can automatically select, where group chat agent can automatically select the next agent with the help of auto method, or we can use round robin method, where it will select the agents in sequence, or it can randomly select the agents based on the requirement. Now, after seeing all these three details, after seeing all these three conversation patterns, now let's understand the fourth and last pattern that is provided by AutoGen in order to solve the complex task. And that pattern is nothing but the nested chat AutoGen. So let's understand what exactly nested chat AutoGen is. So this nested chat AutoGen allows us to solve a complex task, and that too not using a multiple agent, because in group chat agent we have seen that we are using 5 agents. One is group chat and 4 payload agent in order to accomplish a task, and sometimes these many agents are not required in order to solve a complex task. We can solve the complex task with the help of minimum agents as well, and that's the basic concept behind the nested chat AutoGen, where this nested chat AutoGen provides the functionality with minimum agents will be able to solve a complex workflows. Now, in nested AutoGen, it talks to multiple other agents. So you have agent A. Let's see this particular example. Agent A talks to multiple agents like B, and agent A and B talking in sequence are sufficient in order to accomplish a task. So let's understand now. Let's see how exactly this flow works. Let's say we are receiving a user message. So from this, we'll get a user message. User is asking questions. That question first will go to the nested chat handler. Because we have a sequential chat available, in nested chat, there is a one component called nested chat handler, which decides whether to go into that sequential chat or not. You can ignore this particular loop, human in the loop. You can ignore that. The practical implementation that we are going to see, the actual example where we will be skipping this human in the loop, because we are already providing a LLM capability for our agent A, and this agent capacity will allow us to have the automatic conversation. So you can try with human in the loop, but it will every time ask whenever agent A needs to talk to these multiple agents, it will ask for a human input. And in order to avoid that, we are keeping that particular in the example. Then in the nested chat handler, we have a trigger. This trigger identifies is there a need to go ahead and select the nested chat or not. And as it will have a LLM capacity, so it will be able to understand if there's a need, then this nested chat will start the conversation with sequential agent. So the expansion, if you see, it will call this particular sequential chat, and this sequential chat will then start the communications. And here currently you can see in sequence we are calling same agent again and again in sequence, but here you can call agent A to agent B communication, or agent A to agent C communication, or agent A to agent T communication. Though that sequence is also possible. So based on the complexity that you have in your task, you can decide the agents. If your task is really simple, then you can continue the sequence of similar agent again and again. But if your complexity is more, instead of using same agent, you can have different agents, and that will help you reduce your complexity. Why different agents? Because then you can pass different system message to each agent, and that will take care of expanding your application capability, right, to solve multiple tasks. Okay, so that's how exactly the nested chat AutoGen works. So what we can do is now, let's see a quick comparison how this nested chat is different than group chat, because both are there to solve the complex task. So in group chat, basically it enables the conversation with multiple agents, but here in nested chat, it calls the agent only if it is required. So only if the sequential chat is required, it will call that. So in group chat agent, even though if you are asking simple task, it will take some time in order to generate the response, because it is talking to multiple agents. But in the sequential chat, this particular trigger will decide whether there is a need to call the sequential chat or not. If not, if the task is simple, it will end the conversation. Also, in the group chat manager, we have seen group chat manager controls the routing between the different agents. But here, parent agent is A, which is responsible for handling the communication. So all the responses from fellow agent goes to agent A. So in that case, the user in group chat agent, user interacts with multiple agents, but in nested chat, user only interacts with agent A. So all the communications, whatever from here, whatever question that user will pass, that will only interact with this particular agent. So you can see this particular part is agent A part, and all the communication will happen to this particular part only. This middle part, wherever the conversations are happening in sequence, that is completely handled by the agent A internally. So user no need to worry about what exactly happened inside. User just want to ask one question to the agent A, and that's it. User don't want to see whatever things that are happening outside or happening inside. So, and this is best case whenever we are building a chatbot, like where we are having a user which asks questions to the chatbot. And in this case, the chatbot, what exactly happens internally to this chatbot is of no use. There will be a multiple layers in this chatbot which will take care of handling or solving the task. So that user no need to bother about that. User will only bother asking questions to the chatbot. Chatbot will generate the response, but by asking multiple questions to this particular chat handler or nested chat handler, right? So that's the use of nested chat AutoGen. And mostly this is helpful in most of the chatbots. So let's say if your chatbot is to book a air tickets, then that air tickets, right? User will only talk to the air ticket book chatbot, and then the chatbot internally may call different agents. It may call, let's say, information extractor agent, then it may call flight booking agent, it may call a payment handler agent. So those different agents that chatbot will take care of. User no need to worry about whether it is calling payment agent or flight booking agent. User no need to worry about, and that's the use of nested chat AutoGen. So in the practical implementation, now we are going to see a very good example where what exactly we will do is, we will see this particular example where we have a job advisor agent. This job advisor agent, what it will do is a user message will go to this particular job advisor, and the task of job advisor is to understand the user skill, and based on those skills suggest the role first. For that role, what is the market analysis, what's the demand of that particular role in the market, and then find out the estimated salaries. So that's the role. So in this example, what will happen is user will pass the skills, like user may say I am good in machine learning, Python, SQL, deep learning. Then based on these skills, this job advisor is nothing but our agent A. That's what we discussed earlier. All the communications of user will happen only to the job advisor. That's it. There will not be any fellow agents that the user will talk to. Now, the job advisor agent will take care of handling the nested chats. So based on these skills, this role suggester will suggest several roles. Let's say it will suggest ML engineer is one role. Then it will suggest AI engineer as another role. Then it may suggest data scientist. Let's say these are the three roles suggested by the job advisor, by the role suggested agent. And you can see every time job advisor is communicating with this particular role suggester. So these communications will be handled by job advisor only. We don't need to worry, or user don't need to worry that. Then it will pass the summarized response to this. So again, here we will use the summary method to generate the summarized output generated by role suggester, and the job advisor will be passed to the market analyst. And market analyst will do the market analysis and will find out the demand of that particular job role. So it will say that, okay, this is in high demand. All the three actually are in high demand. If there is any another, let's say, demand, let's say data engineer, then it will say, let's say, moderate demand. So that's how the demand calculations will happen in the market analyst. And then it will be passed to the salary estimator, where salary estimator, based on the role, based on the demand of that particular role, it will estimate the salary. So for each role, it will estimate the salary. It will also do a market research and identify what are the salaries that are available for similar job roles, what are the different companies that are offering the salaries, and based on that, it will generate the salary, or it will estimate the salary. And then this complete response. So this is the nested chat. Right. So based on this particular complete chat discussion that is happened, it will generate a summarized response. And that response will then, basically the job advisor is already part of that summarized response. So it will be sent back to the user in the form of the summarized response. And then based on that, user may ask some follow-up questions to this. And accordingly, the job advisor and user communication will happen. And then job advisor will take care of handling the nested chats internally. So isn't it easy? So let's see this practically, how exactly the conversation will happen. So let's open our code and we'll continue the practical implementation. Okay, so this is our project folder. So what we can do is we are learning a conversation pattern. So let's go ahead and create a new file in this particular folder. And let's give the name as job advisor. So I'm creating a IPYNB file. Let me go ahead and select the kernel. This is the kernel that we are using. We are using Python 3.11. And let's start writing the code. So first step is we need to import the LLM configuration. So this is the LLM configuration where we are using Azure OpenAI model where we are using Azure OpenAI subscription. And from there we are using GPT-4 model. So if you have missed this particular part, this I already covered in first session of this particular playlist. So go ahead and check out. The link is there in the description. So in order to import that, what we can do is we can use this particular code. We are importing convertible group chat and group chat manager is not required now. So let me remove that. And then what we need is we need to read the LLM configuration, and in order to read the LLM configuration, we need to go one step back because the LLM configuration is available at root level. So we are going one step back and importing this dependency or importing this LLM configuration. So let's execute that. It is successful. Now the task begins where we need to define the different agents. So first of all, let's define the job advisor agent. So for job advisor agent, what we can use is again the convertible chat agent class that is available in the AutoGen. So this is the class, and in that again, just like our normal things, we need to define the two parameters. So first of all, we need to define the name. Name is our job advisor. LLM configurations we are passing. Here, right, as I mentioned earlier, we can decide is the LLM configuration whether to pass or not. Currently, we are setting human input mode as never because we don't want a human interruption in between. And that's where we need LLM configuration so that this job advisor will take decisions by its own. Whatever these things we have seen, the job advisor talking to these agents, right, that will be handled by job advisor automatically. And that's where we are passing this human input mode to never and the LLM configuration. And max contributor auto reply we are setting to 1 because for this particular example, we know that we don't need to call the similar agent again and again. So this role suggester job advisor need to call only once. Each agent it needs to call only once to generate the response. If you are not sure, right, in your example, how many times this particular conversation will happen between two agents, then you can set another method of termination, that is each termination tag. And then you can set for each fellow agent the capability to pass termination message once the conversation is end. So let's keep it simple for this example. Similarly, we need to build another agents, those 3 agents. So let me just show you those 3 agents one by one. So first one is the agent 1, which is to find out the relevant job roles. So we are defining variable role suggester. Again, we are using convertible class and we are giving name. System message, let's see what we are giving is you are an expert in career coaching. Suggest 2 to 3 job roles based on user skill. That is what we are defining a system message. And that's where I mentioned, right, if there is a complexity in your agentic framework that you are building, instead of using similar agent, you go ahead with the different multiple agents. And that's where for each of these, right, role suggester, market analyst, salary estimator are the different agent. But this particular diagram we have see where we are calling agent A to agent B in sequence multiple times because it depends on your complexity of task. So here you cannot request role suggester to do a market analysis. See, you can add that functionality, but in order to keep the accuracy into consideration, in order to improve the accuracy, we are defining different agents. But yeah, if your task is really simple, you can go ahead with similar agent. You don't need to define. Instead, you just need to define the system configuration, existing message, and you need to add a proper guidance to that. You need to add a proper prompt. Then agent 2 is to understand the market demand. So again, we have given name as market analyst. You analyze job market trends for a given role, those 2-3 roles, and response with high, moderate, or low demand with one-liner description, right? One-liner reason. So this particular 2-3 job roles will go to job advisor. Job advisor will call to market analyst. Market analyst will find out the moderate, high, and low demand for those jobs. And then again, that response will go to job advisor. Job advisor will then go to the salary estimator to estimate an average annual salary for a given job role in USD. And again, it will respond in one sentence. So the summary of output generated by this will go to job advisor. Again, it will generate the summary based on that summary generated by these 2 agents. And at the end, it will generate the final summary. So, and you can see we have given human input mode as never and LLM configuration we have passed. So those 4 agents we have built now. So as per the discussion, job advisor first agent and those 3 fellow agents we have defined. Now let's see how we can define a nested chat. Okay, so for nested chat, we need to define this particular part now. This nested chat, how these 3 agents and job advisor will talk to each other. So you can see In nested chart, the first recipient is role suggester. Now this is the variable that we have created, but the name is different. Name is this role suggester, right? So we are just giving the variable name, first agent variable, and then message we are passing suggest 2-3 job roles based on the skill, right? And then market analysis, it will do the market analysis, and summary method, you can see we are passing reflection with LLM. So the response generated by this will be a summary which is passed to the job advisor agent. Similarly, then second recipient is market analysis, third recipient is salary estimator. And again, max term is 1 because here we are not using any another termination method. Instead of that, you can use is termination flag. It depends on your conflict. So we have defined those. Now it's time to register these nested charts with the job advisor agent. So in order to register that, we can use this particular code here, job advisor dot register nested chart. Now this is the component that is available. You can use that component in order to define in order to build the connection. So between this job advisor and these nested agents, we can register these to job advisor so that job advisor will have this feasibility to talk to these agents. That is what we have defined here. We have given this nested chart a nested chart list, and then trigger. We are giving feasibility for job advisor to trigger which agent it wants to trigger. So we are writing this particular code like where sender is none or sender is not in this particular agent. If the agent sender is not from this list or it is none, then only job advisor agent will be called, or else it will keep calling these agents. So this will define, or this will give feasibility for job advisor to understand which agents to call next, right? And let's execute this particular part. So basically what will happen is this job advisor will only execute if the message is coming from user, because there is only going to be the 2 conversations from user and job advisor. So this job advisor needs to understand whether a agent is talking or whether a user is talking. So this particular code will take care of that okay, it is not, the response is not none or the response is not from this fellow agent, but the message is coming from the user, and that's where it will trigger. So to understand the trigger, we need this. So let's see, job advisor is not defined. Okay, sorry, there is small mistake. So here it should be job advisor. Okay, now this is done, and now we can start the communication. So in order to start the communication, what we can do is we can save the response in reply, and job advisor dot generate reply. We can use this particular capability of job advisor in order to start the conversation. And in the message, now from user, the role is user, but user is saying that I have a skills in Python, data analysis and machine learning. What job should I go for? Now, based on this input message from user, job advisor should identify the fellow agent and do the market and understand the roles, do the market analysis and give the salary estimations. So this job advisor agent needs to take care of understanding the user need, and accordingly it needs to call the different agents to perform the task. So user no need to worry about what is the roles that are available, what is the salary, what is the demand. The job advisor agent will do everything for that, for the user. So let's execute this. Okay, so you can see now the chat has started, and you can see first we have asked the question to job advisor. So this question goes to job advisor, and job advisor have started the task. So job advisor first calling to role suggester, and it is suggesting 2-3 job roles on my skills, and it has passed these skills. Because job advisor have a LLM capability, it has extracted these skills from user message and passed the suitable message to the role suggester, right? Then role suggester have given the response to the job advisor saying, given are the skills in Python, data analysis, given the skills, these are the job roles: data scientist, machine learning engineer, data analyst, with one-liner description. And you can see it has terminated because we have given max turns health 1. Then it is starting a new chat. You can see the job advisor is starting a new chat because it's a nested loop. It is terminating this first talk with role agent, and then it is calling to the market analyst. And now what job advisor is doing, summarizing the response. You can see, analyze the market demand for these job roles. You can pursue job roles such as data scientist, machine learning. So it has extracted the response from role agent and passed it to the market analyst. Then market analyst has given the response, high demand for all roles due to increasing reliance on data-driven decision making and automation. So it has given high demand for all, and then it has terminated. Then again, job advisor is starting a new chat. Then it is calling a salary estimator, and now you can see it has generated the summary of all the three. So estimate the average salary for the job roles. You can see it has given job roles. Then it has given there is a high demand for each. It means the method that we have passed, this particular reflection with LLM as a summary method. So the LLM is generating the summary and passing the responses. Then salary estimator has given the response as the annual salary in the United States are approximately $96,000 for data scientist, $112,000 for machine learning, and $68,000 for data analyst. So it has given that salary, and then it has terminated the chat. And then the final recommendation generated by a job advisor agent. This message go to the final user that okay, the job roles of data scientist, machine learning engineer, and data analyst are in high demand, leveraging skills in Python, data analysis, and machine learning. And they are offering a career growth and specialization with estimated US average salaries, annual salaries of $96,000, $101,000, and $68,000 respectively. So this response will go to the user. Now user no need to worry about what's the internal conversation that is happening, or which agents are getting called, and what is the thing that is happening. User knows the capability that if I'm asking questions to the job advisor based on the skills will suggest the roles, the demand, and the expected salary. User no need to worry about anything at all. No need to talk to individual agents. The job advisor will take care of handling everything and generating the response. So that's how the complex task can be solved with the help of nested chat. I hope you really like this particular video because we have covered each and every point in a really neat and clear manner. So if you have missed any previous videos, I would highly recommend go ahead and see. That's how it will become more clear for you how these nested chat conversations happen, how the agent conversation happens. So with this, we have covered all the conversation patterns that are available in the AutoGen. If you want to learn more about Azure OpenAI, how you can build a generative AI applications with the help of Azure OpenAI, then I have prepared a whole Udemy course on that. I would recommend go ahead and check out the course. The link is available in the below description, and the link to the complete playlist is also available in the description. So go ahead and check out that list. Check out that playlist as well. So I hope it was a good learning for you. But keep learning, and see you soon in the next interesting video. Thank you so much.